Good morning, class. As we have started exercise of language of chemistry, this we will continue today up to question number 4. I think up to question number 4 we have done already. So we are going to start from question number 5. So let's start. Question number 5. Here we need to write the I'm reading the question once. The valency of aluminium is 3. Write the valency of other radicals present in the following compound. So here 4 compounds of aluminium are given. So there we need to write down the valency of the other radicals other than aluminium. So as we are writing in a table form in our last questions, the answers we have written in that manner, so that in that manner only we are going to write. So here, though it's not asked, but we will be writing the uh, molecular formula of the compounds given. Okay, and from that we are going to write down the radicals, and then we will be writing the valency. So compound molecular formula. I am writing in short because much space is not there. Radicals and valency of anion we will be writing. Valency of anion. Why we are writing this? As aluminium is the positive part, that means this is the cation, so its valency is already given on in the question, that is 3. So here only we are writing the valency of the anion. Okay, that means the negative part. So we have to write down the columns. It's not So the first one is aluminium chloride, number A. This is the name of the compound. So its molecular formula is AlCl3, aluminium chloride. Aluminium's valency is 3, chlorine's valency is 1. So this will be the molecular formula. Aluminium's valency will go to chlorine, so 3, and chlorine's valency will come to aluminium, that's why 1. Okay, so radicals present will be Al3 plus aluminium and chloride Cl minus. Okay, these two are the radicals. Now from the radical we can easily write down, we can easily guess the valence of anion. So that will be 1. Okay, valence of anion is 1. Next, number B, that is aluminium oxide. Aluminium oxide. Oxygen's valency is 2, we know. Aluminium's valency is 3. So just we have to cross it. So Al2O3, this will be the molecular formula of the compound. So here radicals present will be aluminium, same Al3 plus, and oxygen oxide, that is O2 minus. Now from this valence of anion will be 2. Achha, you do one thing, you make you just draw line in between so that one cannot mix with the other. Okay, next number C, that is aluminium nitride. Acha, this is not nitrite. Okay, nitride. So aluminium nitride, this is ALN, nitride radical. So here I am writing once, nitride, this is N3 minus. Okay, this is the nitride radical. So N3 minus, so both are having valency 3 3, that's why side by side just their symbols will be written. Achha, radicals, aluminium Al3 plus and nitride is N3 minus. So valency of anion will be 3 here, nitride. Achha, next number D, aluminium sulfate. Number D, aluminium sulfate. So molecular formula will be, aluminium's valency is 3, we know, and sulfate is 2. Sulfate's valency is 2, SO4 2 minus. So Al2 SO4 whole 3. Okay, aluminium's valency will go to sulfate, this whole SO4 with SO4, this 3 will be there, and sulfate's valency, which is 2, that will come to aluminium. So Al2SO4 whole 3. This will be the molecular formula for aluminium sulfate. Now radicals present will be aluminium as it is, Al3 plus, and sulfate is SO4 2 minus. Okay, now from this valence of anion, how we will write? This will be 2, valency of sulfate. Achha, next next question, question number 6, that is variable valency. So the definitions, you know, you are going to get that in book. So for that you have to read the book thoroughly, line by line. You can get the definitions there. So variable valency, we know what is that. When one element can have more than one valency, that phenomenon or this we are calling as variable valency, that the valency is variable, it may be more than one. So examples are required for this variable valency. The element which can show, that is many are there. A common one is iron. Iron can show +2 and +3, these two valencies. So as we know, iron can show two valencies. One is iron 2 plus, that is called ferrous, and another is iron 3 plus, that is called ferric. So this is ferrous and iron 3 plus, that is ferric. Copper also can show this variable valency, where copper +1 we can get. This is the lowest valency. So this is cupric. This is cuprous. Okay, lowest valency cuprous, and copper 2 plus, that is the higher valency, that is cupric. So these two example you can give, or other than these two, lead is also there, lead 2 plus and 4 plus. teen is also there, teen plus 2 and plus 4. So many are there, so that you can use here. Okay. Gold is also there, gold plus 1 and plus 3. So these are there. Next, question number 7. So these questions, let me read the question once. What is a chemical equation? Why it is necessary to balance a chemical equation? What are the limitations of a chemical equation? Okay, all these questions, all these answers of these questions you can get in the book. Okay, in book it is written properly, so from there you will be writing. So answers of these questions we have already discussed in class. So and in the book also you will be getting that in point wise. So from there you can write that. Okay, point wise you have to write limitations and why we need to balance a chemical equation. These are okay. Next, question number 8. What are the ways by which a chemical equation can be made more informative? This also we have discussed in class. So in that manner, in point wise you have to write. Okay. Next, state the law of conservation of mass. This also you are going to get from the book, so read the book thoroughly. These questions are already discussed in class also. Next, differentiate between reactants and products. Okay, and balanced and unbalanced chemical equation. So this where you are going to get, I'm telling. Question number 10. Reactants and products. Reactants means the substances which will react to form which will react during the chemical reaction. So those are the reactant, and products are the substances which after the reaction we are going to get, that are those are called products. Okay, page number 61. There you are going to get. See, reactants are the substances that are used as the starting material, means which we are using during the chemical equation, during the chemical reactions, and which react with one another are called reactants, and the substances which are formed as a result of reaction are called products. Okay, these are very easy. So from there you can write that. I'm not wasting much time on this. Next, a balanced and unbalanced chemical equation. See, for differentiate between reactants and products, you can take an example. Any reaction, suppose reaction between hydrogen and nitrogen to form ammonia, NH3. Okay, so this reaction you write in both the columns. When you are writing the differentiation, when you are writing the you are differentiating between two substances, as we are doing, as we write generally, you have to make a column. Okay, so one side reactant, one another side product. Okay, and there here, after giving the definition, you use this example between hydrogen and nitrogen. Okay, then ammonia. So there you write products, these are the reactants, hydrogen and nitrogen, and this is product. So that you mentioned. Okay, reactants, and this is product. For balanced and unbalanced chemical equation also same thing. The first differentiation, first point will be their definitions, and then after that you will be writing a balanced chemical equation. Suppose, see how to write this. Just this format I am showing once. Suppose balanced chemical equation and another is unbalanced chemical equation. Okay, so first of all the definition you will be writing. Okay, the definition will be the first point, and number 2 the second point. You have to, here the first point will be the definition. In short I am writing, okay, definition of unbalanced chemical equation you will be writing, and here the definition of balanced chemical equation. And next number 2 the second point, here you just write a chemical equation which is balanced. Okay, suppose the reaction between nitrogen and hydrogen only I am taking ammonia NH3, or other than this any balanced chemical equation you can use here. Okay, so here we need 3 hydrogens and this will be 2. So this is a balanced equation. Now here the unbalanced form of this equation you will be writing in this part. Okay, so only the skeletal equation we are writing here, nitrogen plus hydrogen, we are getting ammonia NH3. Okay, so this is the unbalanced equation. So here one thing you remember, the same reaction in both the sides, the same reaction you have to use. Suppose here you are using a balanced equation and here another unbalanced equation you are using, that will not work. The same equation, so one is balanced form, another is unbalanced form. You have to write, then only we can understand the difference. Okay, so in this manner you write down the difference. Next, question number 11. Here you need to balance the following equations. Okay, how to balance the following equations? This was also given in worksheet. So let us solve this. Question number 11. Balance the following equations. So number 1, nitrogen plus hydrogen. From this we are getting ammonia. Just now we have done the balance. As 3 hydrogen is there this side, so here we have to multiply this with 3, and as number of hydrogens are 3 into 2 6, so we have to make it 6. So if we write before ammonia, if we write 2, then nitrogen also will be balanced and hydrogen also can be balanced. So this is the balanced form of this equation. Next, number B. And this balancing, as much as you can, you just practice, then it will be more easy for you to understand that how we will balance it. Next, hydrogen plus oxygen, we are getting water. Okay, H2O. See here 2 hydrogen is there, and here also 2 oxygen atoms are there, and this side only 1. So here must be 2 to balance oxygen. Now as we are writing 2 this side, so hydrogen now becomes 2 into 2 4. So if we write 2 this side, 2 into 2 4 atoms of hydrogen we are getting. Okay, so this will be the balanced form. Next, number C. Na2O plus water, H2O. We are getting sodium hydroxide, NaOH. How to balance this? See, as Na2O is there, that means 2 sodium is there. So this side at least 2 sodium will be there. So let us write 2 first. Now if we are writing 2 this side, how many oxygens are there? 2. And this side 1, here 1. So oxygen is balanced. one oxygen atom, and this side with water, one oxygen atom. So oxygen is balanced. What about hydrogen? This side two hydrogens are there, and this side also two hydrogen. So all the elements are balanced now. Next, number D, CCO plus O2. When carbon monoxide react with oxygen, we are getting complete combustion of carbon, that is carbon dioxide. So how to balance this? Here we are having 3 oxygens, 1 and this side 2, and here we are having 2 oxygen. So if we write 2 this side, now how many oxygens? This side 2 and this side 2, total 4, and this side 2 is there. So how to make it 4? If we write 2 this side, if we write 2 this side, then oxygen will be 2 into 2, 4. What about carbon? 2 carbons are there this side, here also 2 carbon. So it is balanced now. So this will be 2. Okay. Next, number E, zinc Zn plus HCl. Okay, zinc plus HCl, ZnCl2 plus hydrogen. Now see, ZnCl2, that means 2 chlorine is there. So from where we are getting the chlorine? Only from HCl we are getting the chlorine this side. So there must be at least 2 HCl, otherwise how we will get the chlorines? Okay, so if we write 2 this side, how many hydrogens? 2 hydrogen is there, this side also 2 hydrogen, 1 zinc, here 1 zinc. That means this is the balanced form of this equation. So Zn plus 2 HCl, ZnCl2 plus H2. So students, that's all for today. A few questions are left which we are going to do in our next class. Okay, till then you practice this, write down the answers in your exercise book, in your school's copy, and practice this balancing. Okay, more you will practice, more you will easily you can do that. Okay, so doing that way, have a good day. Okay, thank you.